Have you ever wondered how computer programs work? Let's embark on an enlightening journey to unravel this mystery. To start, we need to understand what a computer is. A computer, put simply, is an electronic device that processes input from a user and produces results. It's much like a diligent worker, doing exactly what it's told. Now, this worker has several key components. The input unit is like the ears, listening to what you tell it. The central processing unit, or CPU, is the brain, coordinating all the operations. And then there's the output unit, the mouth if you will, that communicates the results back to you. The CPU itself has several subunits like the arithmetic and logical unit, control unit and memory unit, all working together like a well-oiled machine. So that's the basic framework of a computer. Now let's dive into the programs that make it work. So what exactly is a program, or in other words, code? Let's unravel this. A program is essentially a set of instructions that you give to a computer to perform a specific task. These instructions need to be clear and precise because computers, while incredibly powerful, aren't intuitive like humans. They don't understand context or ambiguity. They need explicit instructions, and that's where programming comes in. Let's illustrate this with a simple example. Suppose you want to find the average of 10 numbers. How would you do it? You'd add up all the numbers and then divide the sum by 10, right? But how would a computer do it? Well, you'd have to tell it exactly what to do, step by step, using a program. First, you'd instruct the computer to take 10 numbers as input. Next, you'd instruct it to add these numbers together. Finally, you'd instruct it to divide the sum by 10 to find the average. This set of instructions is what we call a program, or code. Now you might be wondering, how does the computer understand these instructions? Great question. Programs are written in specific languages that computers can understand. These are called programming languages, and there are many of them, including Python, JavaScript, and C++, among others. Each of these languages has its own syntax and rules, just like human languages. The difference is that programming languages are designed to be unambiguous and highly structured to prevent any misunderstanding. When you write a program, you're essentially writing a recipe that the computer can follow to achieve a desired outcome. The beauty of programming is that it allows us to harness the power of computers to perform tasks quickly and accurately. From simple calculations like our average example, to more complex tasks like controlling rovers on Mars, processing medical data, or even creating special effects for movies. That's a basic example of a program. Next, we will discuss how to create these programs. Now you might be wondering, how do we create these programs? Well, when we talk about programming, we're essentially talking about a problem-solving process. It's all about translating our human thoughts into a language a computer can understand. This process can be broken down into three main steps: problem definition, algorithm design, and coding. So let's start with the first step, problem definition. This step might seem straightforward, but it's often the most tricky. It's all about understanding the problem we're trying to solve and what we want our program to achieve. For instance, if we're writing a program to calculate the average of 10 numbers, we need to clearly define what these numbers are and how we obtain them. It's crucial to be as specific as possible in this step, because a well-defined problem is easier to solve. Once we've clearly defined our problem, we move on to the second step, algorithm design. An algorithm is a step-by-step procedure for solving a problem. It's a bit like a recipe. If you were baking a cake, you'd follow a recipe that tells you what ingredients you need, how much of each one to use, and the order in which to combine them. Similarly, an algorithm provides a detailed series of steps that the computer will follow to solve the problem. So, in our average calculation example, our algorithm would include steps like taking inputs, adding them together, and finally dividing by the total count. The final step in our programming process is coding. This is where we translate our algorithm into a programming language. There are many programming languages out there like Python, JavaScript, and C++, each with its own strengths and quirks. This step involves writing out our algorithm using the syntax and rules of our chosen language. We do this using a text editor or a specialized tool called an Integrated Development Environment, or IDE, which offers useful features like code highlighting and error detection. This stage can be a bit like learning a new language, but with practice, it becomes second nature. Throughout this process, it's important to remember that programming is iterative. It's rare to get everything right the first time. You'll often find yourself going back and forth between steps, refining your problem definition, tweaking your algorithm, or correcting errors in your code, and that's perfectly normal. In fact, it's part of the fun of programming. The constant learning, problem solving, and improvement. So there you have it. From defining the problem, designing an algorithm, through to coding, these are the steps involved in creating a program. It might seem like a lot to take in at first, but with practice, you'll find that it becomes a natural process. And remember, every programmer, no matter how experienced, started out exactly where you are now. And that's how a program is created. But why should you learn programming? Why is programming important? Why should you learn it? These are questions often asked, and the answers are as varied as the individuals posing them. Yet, there are some universal truths that apply to all. Let's explore those. Firstly, programming is the backbone of many industries today. It's no secret that the tech industry is booming, and it's not slowing down anytime soon. Companies are always on the lookout for skilled programmers. Whether it's developing software applications, building websites, or creating mobile apps, programming skills are in high demand. Learning how to program can open doors to a wealth of career opportunities. But it's not just about landing a job or chasing lucrative salaries. Programming is also about problem solving. It's about breaking down complex issues into manageable pieces, figuring out logical steps to address them, and then translating those steps into code. It's about using logic, creativity, and tenacity to find solutions. In a world filled with problems, this is a valuable skill to have. Moreover, programming allows us to automate tasks, analyze data, and even predict trends. It's an essential tool in many scientific fields, from computational biology to astrophysics. It's used in the financial sector for algorithmic trading, risk assessment, and data analysis. Even artists and musicians use programming to create interactive installations and generate new forms of digital art and music. Beyond that, programming has the power to change the world. It's the engine behind social media platforms, search engines, and e-commerce sites that have transformed how we communicate, find information, and shop. It's also the driving force behind innovations that are addressing some of the world's most pressing challenges. From creating software to help track and mitigate climate change, to developing algorithms that can detect diseases earlier and more accurately, programming is playing a pivotal role in shaping our future. So, programming is not just about coding, it's about making a difference in the world. It's about creating, innovating, and solving problems. It's about pushing boundaries and opening up new possibilities. And that, in essence, is why learning programming is so important. In a nutshell, programming is a powerful tool in today's digital age. It's more than just lines of code. It's a language that lets us communicate with machines, create solutions, and bring ideas to life. We've explored some fundamental concepts in this video. We've learned that a computer is an electronic device with an input unit, a central processing unit, and an output unit. It takes our instructions, processes them, and delivers results. We've understood that a program is a set of instructions we give to a computer to execute a specific task. It's like a recipe the computer follows to cook up the results we want. From finding the average of 10 numbers to more complex tasks, we can write programs to solve a myriad of problems. We also discussed the steps of programming, from defining the problem we want to solve, designing an algorithm, and finally, translating that algorithm into a programming language. This process is like constructing a building. We start with a blueprint, gather our materials, and then start building brick by brick until we have a finished structure. And why learn programming? Well, the applications are virtually limitless. It can propel your career in software engineering, help solve real-world problems, and even control Mars rovers or create movie special effects. It's a skill that opens up a world of possibilities. Now, there are a variety of programming languages to choose from, like JavaScript, Python, and C++. Each has its strengths and uses. JavaScript, for example, is commonly used for web development, while Python is popular for data analysis and machine learning. C++, on the other hand, is used in system programming and game development. The key is to choose a language that aligns with your goals and interests. Remember, the power to create amazing things is at your fingertips with programming. So, what are you waiting for? Start your programming journey today.